Welcome to the first job scheduler webinar. This is Lorenzo Cantelmi, working for INRIA for the work package for Cloud Hosting chapter related to the FI-WARE project. In this presentation, we will describe briefly what's behind the job scheduler generic enabler. Basically, the main requirements come from seeing the evolution of computing system. Since the beginning, from batch systems till now, the new trend is the cloud computing. Some concepts still remain the same, such as the needs of model activity through job. Model the computer resources via resources, and the possibility also to schedule job across the resources are a concept that still keep the let's say last during the time. Related to this concept, across the time, the main requirements are portability for the job, create an homogeneous representation of the resources, also offer an easy way to manage this kind of resource. While for the scheduler point of view, the main requirement is increase the overall productivity, that is function basically of the resources and the jobs, the running activities. We see here that while for batch systems and personal computers, let's say the devices are standalone, so computing systems are standalone, living in a given device. By grids and clustering system, and so also with the cloud computing system, all the communication start to be distributed. So the resources needs to be modeled according to cover this kind of distributed model. While the three first computing systems deals with physical infrastructure, cloud computing strength is about the virtualization. So that we need, from enterprise point of view, a way to gather all these kind of resources in order to don't waste what enterprises have, in order also to be able to schedule these jobs model as XML across this kind of resources. The accessibility to the computing resources, in the case of our implementation, is achieved by thanks to ProActive middleware that is part of our baseline. This middleware, as we saw before, is a requirement to deal with a distributed system. So by enabling this the computing system to be part of the middleware, you can start model the resources and get an homogeneous representation of them. In our case, those abstraction have been done through JVM technology. In particular, with ProActive library, you can you can enable these resources to be part of the middleware in order to accomplish an hybrid business model. The portability we saw before is translated in XML job definition. About instead of using VMs, we use JVMs abstraction to model the resources. Going to the architecture of the job scheduler. Dealing with the middleware, it might be complex to understand the architecture, but what I want to let you think is an octopus style architecture where we have a scheduler entity that leverage the resource manager resources. The main role of the resource manager is to abstract, as we said, the computing resources through the nodes that are basically the tentacles used by the scheduler to accomplish the tasks. All the communication pass through a message queuing system that represent basically the nerves of this kind of monster. Inside the job scheduler, we have the REST interface that offer a representation of the scheduler and the resource manager, and the main capabilities to interact with the entities such as jobs, tasks, nodes, etc. Once we will address some issues, improve basically this REST API, the idea is to also leverage the portal and the huge ecosystem that the baseline is could offer. The baseline is, we remind, ProActive parallel suite. We go ahead. We saw before that also there is the concept of the data space, where basically is a place where the results of the task can be stored and pushed. Coming to the jobs definition, what is from abstract point of view a job? A job might be modeled as a composition of task. Overall, a task is the smallest schedulable entity in our case. More technical speaking, a job is a task flow. This means that you can define dependencies between tasks in order to define the execution of the flow. Actually, the type of tasks supported are Java tasks that consist of extending by implementing a specific interface of the ProActive. We have also a native, the possibility to define a native task that is basically bound to a specific architecture or platform that on where the nodes is deployed. And also we have a multi-node task job. That means some jobs require the execution of task according with, for example, a master-slave architecture. So it's quite flexible, as you can see. Giving a better example, just to let you understand what we are speaking about. Here is an example of native job. where we define the location on the schema, the description. We can define the description, where the input space and the output space that represent where the data should be fetched and pushed according with the needs of the user. Also here we define the task flow, the actual task flow, consisting of just one task that execute a selection script. A selection script is a way to say to the resource manager, I want this resource, I need this the node with this certain type of characteristics that might be tied to the operative system, as it might be the case where we here select a Unix system to accomplish this native job, native task. We see that how we can define the static command to execute the native task, passing also the parameter to the function as argument. We go ahead. The perception from user point of view of the whole architecture could be resumed like this. So the user access the scheduler, and then they push their job. Inside the job we saw that we can define the selection script that are executed at the resource manager level. The resource manager will check the availability of the nodes. We will reserve them according with the criteria defined, and then once reserved the node, the scheduler can push the tasks on top of these nodes and get the results. Here we introduce you a potential look and feel for the scheduler, the scheduler portal, but we will see it in more details later while doing demos. A bit more complex is the resource manager architecture, since basically the main role is, as we said, to abstract the computing resources in terms of nodes. These nodes can be gathered, aggregate in infrastructures. An infrastructure can be dedicated for specific goals, such as here we have cloud infrastructure or cluster infrastructure. Together to the definition of the policy, we define the node source, that is basically, as we said, let's say the set of infrastructure at the policy. The policy defines basically the mode how you can acquire the nodes. Static means at the boot time of the resource manager acquire the nodes, or you can define acquisition of the nodes according with the load of the scheduler. Other components are the monitoring and the selection manager. The selection manager takes care about the selection, execution, the selection script. The monitoring is the way to monitor the status of the nodes. Go ahead. Here there is the potential look and feel after the integration that we could address. Is still under discussion, but our idea, since the ecosystem is rich, we would like to offer the easiest way to the user to access the potentiality of this job scheduler. Futuristic scenarios could involve several protocols. We say that being nodes distributed, we need to offer several ways to communicate, since some protocols are typical for LAN environment, but others are suitable to go across internet. So that from nodes point of view, the topology might be peer-to-peer or client-server. In the case of PMR, that is our implementation, our implementation it consists basically in a software router where the nodes connect to, and the communication pass through this software router in such a way that we don't have issue from firewall point of view, since the communication is just outgoing. So we don't have specific issue related. We have also RMI, PMP, HTTP protocols that relies on peer-to-peer communication. RMI, you might know that has a centralized registry, but according with our architecture, also each node can have his own registry and start communicate. Other capabilities are related to tunneling mechanism. So RMI, for example, might be tunneled in SSH or SSL, but the idea is to start with RMI, since as we will see, the job schedule will be shipped in a box, standalone box, and then increase the infrastructure definition. MQP has basically the PMR type of architecture, but is an open source solution and standard and interoperable. We have some issue in okay. Focusing on the cloud hosting chapter, what could be the role of a job scheduler? In the cloud chapter, we have a device, the Cloud Edge, that has a low performance in terms of computation. So whenever needed, this kind of device can forward some jobs to the job scheduler. Moreover, also edgelet that are applications running on this Cloud Edge can leverage this job scheduler. But in general, is a generic purpose generic enabler, and might be suitable also inside the data center, since usually in data center you need to perform periodic computation, recurring computation. So it might be useful also to accomplish scenarios where an integration with the IaaS data center resource manager could be involved. Basically, we cover a short time or temporal business model that actually in the cloud computing now is not covered yet. Potentially, through the definition of the jobs and tasks, you can imagine easily that we can act like a PES. It's basically you can run, you can configure your nodes according with your needs. So we propose the main links that concern the job scheduler. We describe briefly the job scheduler architecture. We have in the previous slides that I'm gonna furnish after the webinar. We see that the job scheduler is consists of basically a box, as is supposed to be. The interface to external worlds can be done at the moment through the REST API that offer representation of the scheduler and the resource manager. As you can see, user can access the REST API as well as the other FI-WARE generic enabler. The main components are the scheduler and the resource manager, as I told you. Inside, in order to enable this module to actually do computation, we need to deploy some nodes on it. So the job scheduler is shipped with a local infrastructure consisted of basically 4 nodes that are available for computation. I will act like admin once it will be on testbed, and why not? I will, gathering requirements time by the time, we can imagine scenarios where we can have other infrastructure also dedicated to specific project. All the communication pass through this message queuing system. As we see, the main entities to interact with are for the job scheduler, the jobs and the tasks. While for the resource manager, node source, infrastructure, nodes and policies. We can pass to the records. Okay, copy paste the URL. Okay, this is the demo related to the resource manager service. There is the audio, so I guess we can whenever you have question, I will stop it in order to answer you. I suggest you to put the highest quality in order to display it. The original is the right one, and I will start it. And you can also have a full screen view in order to see all the details. I try to be comprehensive in my exposition, so whenever you have anyway doubts, just tell me. Here we go. Welcome to the Job Scheduler webinar. Before starting the demo session, we would like to remind you the architecture of the job scheduler that is delivered. That consists of a REST server that offer the representation to access scheduler, resource manager, resources. Those are the main modules embedded inside the job scheduler, which consists also of some nodes deployed always locally in a local infrastructure, and that leverage it to accomplish computation tasks. We see also there is a global data space where the user could push data to process and get them. Actually, the REST API does not support a push-pull mechanism to the global data space, but we are addressing this this kind of issue. We are gonna provide these two ways to put and get data inside the job scheduler. In such a way, user and other generic enabler could process their data. The idea is to start with just a local infrastructure, then me acting like the admin, to extend to other infrastructure in order to let the job scheduler infrastructure grow incrementally, and also to control all the let's say the life cycle, getting also useful requirements and specification. Okay, we are ready. We go. I've built some script to help me in managing these demos in order to have a concrete representation what is the action after a REST API invocation. We leverage the portal, the ProActive portal, and bot from the scheduler resource manager that are part of the our baseline. So the idea is to later on to modify the REST API in order to be to integrate with other generic enabler, and according to that also insert the portal, but everything is also still under discussion. So we go. We start from scratch the job scheduler, let's say, installation. Is not actually an installation, it's just a matter of launching it, since it's already pre-configured. We see that we can furnish some parameter and launching it to the JVMs bound to the scheduler and the resource manager. Here we set up the host name in order to specify explicitly the URL. In here we are gonna launch the REST and the portal web services, where we insert, we furnish the host name, the words are deployed. The words are furnished as well are available in the here of the scheduling folder. Also here we have parameterized the host name that we furnished before. Again, we furnished the example to launch the services that characterize the job scheduler. We refresh the pages and we are interested to the admin, to the resource manager. So we go. We see here the local infrastructure for nodes available. They are free, as we see here. More details are about the status of the nodes here. There is a possibility also to add nodes. But we will proceed through the REST API, and we will get the look and feel of the action with the corresponding action from the web portal. We launch the demo again. No. We launch it. We had the wrong insertion. Okay, we launch it. This time we copy from here. Here we go. This is a simple request to login. There is login resource where we furnish the username and password. Those details are since the job scheduler is shipped with a pre-built accounting system with authorization and authentication. We use the admin since he has the highest privileges to manage nodes and jobs. So it's the right way to explore all the capabilities of the job scheduler without limitation. We start to log in, we get the session ID. We want to see if the resource manager is active. We see here that we achieved the session ID thanks to this tricky command. That basically is a dynamic way to retrieve every time the session ID that might be expire. So we launch it. We should get true as an answer. So the resource manager is running. We want to know the actual status of the nodes. Okay, fine, 4 as we expected. Again, here we want to add another local infrastructure called local node source test. In order to do that, we need to specify the name, the type of infrastructure that is specified in the user in a programmer's guide. There are references to the ProActive manual. What are the other options to fill? Also the infrastructure, the type of infrastructure available could be accessible also through the REST API. There is a method equivalent to the get infrastructure descriptor still available in the guide. We furnish the endpoint of the resource manager. We furnish how many nodes, the number of many nodes we want to bound to this node source, since we remind node source is basically an aggregation of nodes. We define the pinging frequency to basically is a way to understand if the nodes are alive or not still. Here we furnish also the credential of the admin. The credentials are just another way to authenticate an administrator rather than other than password, username and password, but actually are achieved by processing the username and password. So this data, this admin credential could be substituted by username and password. We have also to specify the policy bound to the current node source we want to create. Again, the guide furnishes you the reference of the how to set up the policies. All means that all we open the access to the node source to all users in order to leverage its nodes, and we set the owner, the provider of the nodes, the admin. Actually, this means specify the provider, that is another way to classify the user. Is another principle, technical speaking. We go. We see that the node is deploying. We get up it running. We want to check if the status of the resource manager is up to date. Yeah, the number of nodes are 5. Okay, right, fine. We remove the nodes, the node source. Soon it will disappear. Okay. We check again the resource manager status. Okay. Now what we want to do is to give you an example of registration mechanism. So we start up a node thanks to the ProActive agent locally. We bound it to default infrastructure, since nodes started up via ProActive agent can be bound just to the default infrastructure. So we see here the address, and we see how this kind of registration is comfortable from a user perspective. I want to run some locally in my machine. I want to register on resource manager endpoint that is already available. So there is no deployment mechanism, as we will see later. Okay. We check the node availability. It's true. That means when we start the nodes, it was not visible from a resource manager perspective. Now that it is registered to this resource manager, I tested it if the resource manager can see it actually. So it's just a way to be sure that the nodes is accessible from the user to compute tasks. Okay, we checked again the updating of the resource manager status. We want to remove the node, so we furnish the path, the URL of the node, and we got a true response. That means it will kill the nodes, but the infrastructure will still available. So we go ahead and we check again the status of the resource manager that is up to date. Finally, about the resource manager, we want to show you the deployment concept, the deployment process. That means as user, I want to administrator, let's say, I want to deploy some nodes on request by furnishing all the details. Here I furnish a GCM infrastructure that is an infrastructure specific to do distribution programming with fractal components. Just an example let's say a programmer might need, or basically we see also other parameters. We furnish static policy here. Again, there is a template to deploy this kind of node source. We furnish our custom list of hosts on which to deploy the nodes. That means the deployment process. I am the resource manager. I want to deploy remotely nodes, and in order that might be used by the user. So the deployment is something like a reverse process respect with the registration process. And we launch it. You might think also that this action deployment is something that could be achieved dynamically if the scheduler needs a lot of more resources for accomplish the computation. So it could be really interesting to accomplish this kind of scenarios where you dynamically you deploy nodes that needs to accomplish specific tasks required by users, for example. And we see here that for each physical host, this is our EON grid that I configured to accomplish this demo. We achieve a node, a JVM up and running. We get the status of the resource manager, and we see it's up to date. You can count, I guess. It is fine. We want to remove. Yeah, and we remove the SSH infrastructure. The deployment is achieved by SSH, so there should be also configuration from an infrastructure point of view. That's why we need to full control of the job scheduler infrastructure, and that's why the access from user perspective is just done by REST interface. We would like to limit the access just to as a user, simple user. Okay, we are done. We can pass to the other demo. It was the first. I was a bit shy, but the next one should be okay. I proceed with the second one. This is about the scheduler service. Then we see the last one that is more interesting, since we will show you a real use case where a user could process data for example, process video. So any question? Okay, no questions, so we try to go ahead. Here we go. Now we will deal with the scheduler demo. If previously we saw the resource manager REST API interaction, where basically you could interact with the main entities bound to the resource manager, such as node source, infrastructure, and nodes or policy. Now we will see how we could interact with the jobs and tasks entity bound to the scheduler REST API interface. As we did previously, we will start from scratch everything. So we clear all. We kill the previous status to start from scratch. And we see that here there is no endpoint listening from the web browser. We start up the Schedule Resource Manager with the same characteristics as previously done. And we launch the portal and the web services. Now it's ready with the 4 local nodes. And as done previously, we will use another script to launch the demo. I don't know if you like this kind of demoing, but I feel it a lot comfortable. If you need the script, just drop me an email. Also, let me know your opinion if you like it. We log in to the both the portal, where we will see how the REST API commands will affect the portal. This is the status, initial status. Here there is a main window where all the jobs will be listed. There are several panels to get job infos, output, servers, preview, in case of visualization needed. Here we go. We start the script. We log in as done previously. The command is almost the same, just changing the access to the resource. Instead of resource manager is the scheduler this time. We get the session ID We check if we are connected to the scheduler. We get through. We can proceed a bit faster since more or less we explain the mode how we are demoing. Here we see there is a way to check the status of the scheduler that is started. It's fine. We can proceed to submit the job. The job is the same that one that appears in the user and programmer's guide, and is available on this path, shipped with the release. We operate always as admin, but could be a generic user. We run it, and we see we get back the ID and the name of the job. The job from pending passed to running status, basically executed, and the nodes are booked and busy. We can see how the portal is up to date when the tasks are executed. So for each task, a node is booked, and a node basically is a container of the logical container of the task, and will accomplish its execution. So we go ahead. The script is parameterized, so we choose the job ID related to the previous job to get information about it. We get all the details, all the task, the composite, the job. There are all details, mostly also as important the priority, and the status. It's finished as it appears here. Then we can start to go ahead. Obviously we can access to live logs if the jobs, if we need live logs to know at runtime the status if there is any problem of the job execution. I will get the information. We can now also retrieve the server logs by this simple call. In the level of details could be configured. I will do it since I will be responsible to administrate the Java scheduler. We see all the logs related to the job. We go ahead. We want to retrieve some information related to a job, to a task on the previous job. We would like to get the serialized value. Here we see that this is a simple string printed from the task execution. If you check the job, you understand that is a simple, really simple job. Later we will see a more interesting usage of the scheduler. We get the stats. We see finish the job 1. We all get all details, general details of the scheduler. If I want information about my scheduler account usage, I get the total amount of jobs, the duration, we finished this quick overview. I hope that this has been informative for you. We can have also an overlook here. Finish the task. We can there are no logs since okay, the job is finished. Now we retrieve the same server logs that we saw previously. Job info, general overview. I guess that's enough to familiarize, to understand also what would be the scenario, the look and feel of the user when he could access the scheduler once we accomplish the integration that is not still planned, since we are, as we said before, we are managing the integration with the Cloud Chapter Identity Manager. That's all. We can go to the other demo. Thanks a lot. Before starting the last demo, if you have any question. Okay, we go to the last one. Welcome to another demo session for a job scheduler webinar. In the other two sessions we saw how basically to access the resource manager and scheduler resources through the REST API, and we saw the submission of a simple job. Now we're gonna show you the use case where the user wants to process his own data, but at the moment we had said that we cannot use the REST API since we need a push-pull mechanism. To have a workaround, we will define an FTP server accessible from the user. This FTP server will have an anonymous access enabled. In such a way, all potentially user can push their data, and for testing purpose can fetch, push and get data without limitation. Obviously it's not a secure way, but for the moment, just to give you an idea, is enough. We leverage the capabilities of the nodes to read from FTP server and write on them. Other option could be also HTTP, SFTP as well, but those SFTP might require further configuration. So basically the idea is to provide the global space represented by an FTP server where we have an input folder, as we will see, and an output folder. So going to the right screen, we will have the job scheduler running on the host. We define FTP server as a VM, so such as a guest of this system, running on a virtual machine, as accessible locally from the host. So it's a local LAN. We we prepare everything. This time we'll use directly the port how to submit it. Just to see the status of the FTP server, here the output folder is empty. And going at the input, there is the file that we would like to process as a user. The job that we have defined will fetch this, roughly speaking, this input file in the folder we define, we parameterized. We'll process it, we generate an output.avi file, and then we'll push it in the output space where the user can fetch the processed result. Let's go to see the job definition. Okay, the job basically consists in the definition of some variables that allow the user to localize where the right script are, or which are the right variable to set. It consists basically of executing a task flow characterized by only one native executable task. This called the main coder. This is basically a program to encode to process audio and video file. Before processing this native task, we accomplish the selection of the node, where you might think that maybe these details are furnished by the administrator, that is me, if the job scheduler is deployed in the cloud, but also might be offer some mechanism to discovery, writing just some search script or job task to explore the infrastructure. What are the programs available to the from the infrastructure? Here then we have, after selection, we have a phase to configure the node before starting the computation. So these include the fetching from the input space, the data to process and bring in the working dir, that is the local space of the node that we forced through the working dir specification. The access, as we see, could be as a FTP user or anonymous, and it is best practice to insert the email as we suggest here. Once it is processed, the output API will be generated, and there will be a PostScript that will operate such as a further task that will push to the output space of the FTP server the result. There might be also a cleaning screen to clean also temporary files generated in the local data space, but we avoid that. How are these file achieved? Basically, we took from the path here the example that are delivered already. We check a bit the code that is available. By default is the SCP protocol enabled to transfer file. We saw here that it was an FTP possibility to configure the FTP, so we uncommented the right part and then customize also for the processing of the binaries, since we had some problem processing the video, but setting the right property, the encoding was successful. How I achieve this? Just basically is a matter of browsing the code of the, let's say, packages that are imported to that are in the job schedule class path when you launch it. So this is the other job. I guess that we can start launching the job. So we proceed from the web portal. We select the job scheduler demo. We see also that there is possibility to edit the variables we saw in the heading before the task flow definition, and we launch it. Now here there should be a peak for transferring. Okay, we achieved it from the guest operating system to the host. So there is this peak, there is as you can see, computation done, the guest and the host. Now we would like to see if the selection script worked properly. We need to select obviously the job. We see that we zoom it a bit, since anyway the computation will take a bit of time. We see that the 4 nodes have been selected, so with the right according with the right criteria of the host name. Then a B shuffle means the one node is selected randomly, and then we can fetch the streaming logs. It consists of basically the logs that the process native task is generating. We are at 80%, so we check that there is no yet. We refresh the page on the output space, and we see that one node is selected, since one task is under execution. Now we check that the job is finished, so we can see that also the node is free. And now if we refresh, we saw the result. That is basically those that appear here locally and is be pushed in the output space. We see also some activity from the network and disk, just to show you that I'm not lying. um, we saw in the job that there was some process, especially addressing the coding, the resizing on the video, and we see that is actually accomplished, and also the X-bit MPEG is also the typo codec is done. Now maybe you might be curious about what is the video. Is something, if you want to see it, is something that rocks, let's say. Maybe you know them. Just to enjoy a bit the result. So finally we resize the video to in a more portable format, as might be the intention of the user. That's all. Hope you enjoyed, and it has been informative for you. Still alive. I hope that you could see the video, the last video. Joy, are you still there? Abel? Yeah, what's the feeling? Is good? You understand something? Yeah. Yeah, I don't know. The video URL are available on the spreadsheet. We can see it's really powerful, but it's being so flexible. The platform, the job scheduler is a bit tricky. It takes time to configure and understand all the baseline, since the power of this job scheduler is the ecosystem that is around. Imagine also to have a workflow GUI to build your XML to push on the job scheduler. You can really, let's say, have your data in your server without being let's say in the cloud, and be sure that the data will be processed and pushed back on your own hard disk or whatever. While cloud computing basically is addressing to centralize all the, let's say, the control on VMs. Here you focus on the data processing. It's like something like let's say a backup philosophy. While backing up files, you can have backup at VMs level, but I guess the most powerful backing up is relying on data. So if you imagine also to have inside the data center these JVMs deployed on hosts, and automatize also the backing up mechanism or run whatever, you can really automatize your environment. This is my personal view and what we propose basically, but it takes time anyway. Thanks for listening. I hope you enjoyed, as I did doing this demo and preparing the videos. It takes time, but I hope that it was useful for you. Thanks a lot. Have a good lunch. And we see next time.